Welcome to The Explainer. We use GPS literally every single day, right? But have you ever stopped to think about how it actually works? Well, today we're pulling back the curtain on this incredible technology that lets you navigate your world.
I mean, think about it for a second. It sounds like something straight out of science fiction. You've got these car-sized satellites whipping around the Earth way, way up there, and they have to work together perfectly to find you on a planet that's constantly spinning. It's an amazing feat of engineering.
The best way to wrap your head around it is to think of it like a puzzle. We're going to solve it together. There are really just three key pieces we need to understand. First, the satellite has to know its own exact address in space. Second, we need a common language to describe locations on Earth. And third, there's a secret, super precise message that gets sent down to your device. So let's start with that first piece.
Okay, piece number one, the satellite's diary. Before a satellite can find you, it has to know exactly where it is at any given moment. And, that's not nearly as simple as it sounds, because space is a surprisingly busy place.
You'd think a satellite just follows a nice, clean path thanks to Earth's gravity. But nope, you've got the sun and the moon, which are also pulling on it with their own gravity. And get this, even the tiny pressure from sunlight, from solar radiation, is enough to push it slightly off course. So its orbit isn't a perfect circle. It's more like a complex, wobbly dance through space. So to keep track of all these wobbles, each satellite keeps what we can call its diary. The official name for this data is ephemeris, and it's basically a complete set of instructions for calculating the satellite's exact position and speed at any time. And this diary comes in a few different levels of detail.
There are basically three grades. First, you have the almanac data. Think of this as the quick and dirty overview. It helps your phone get a fast idea of which satellite should be overhead right now. Then you have the broadcast ephemeris. This is the good stuff, the more accurate data your phone uses for your actual real-time navigation. But then there's the precise ephemeris. This comes from a global network of ground stations, and it's so incredibly accurate that scientists use it for things like measuring the movement of tectonic plates. Wow!
So, that's our first piece of the puzzle. The satellite knows where it is. Now for the second piece, how in the world does it describe a location on Earth? Well, it turns out it needs a coordinate system. Actually, it needs three of them, and it's constantly translating between them.
The first language is the satellite's native tongue, you could say. It's a 3D coordinate system that's based entirely on its own orbit, with the Earth's center of mass at the center. This is how the satellite naturally sees its own position in the universe.
Okay, but a satellite-centric view isn't very useful for us down on the ground, right? So that position has to be translated into a language that's tied to the Earth itself. That's where the geocentric system comes in. It uses a simple XYZ coordinate to map any point relative to the planet's center. This is the crucial bridge connecting space to the ground.
And finally, all of that XYZ data gets translated into the language that we all know and love: latitude, longitude, and height. This is the system that actually makes sense for finding a restaurant or, navigating your car.
So the real magic here is this constant, lightning-fast translation happening behind the scenes. Your phone is getting data in one language, and through some really complex math, it's converting it into those map-friendly coordinates you see on your screen, all in the blink of an eye.
But here's a fun little wrinkle. That word height isn't as simple as it sounds. See, GPS calculates your height based on a perfect mathematical model of the Earth, called an ellipsoid. It's perfectly smooth. But we all know the Earth isn't smooth. Its gravity field is kind of lumpy. That real-world lumpy surface is called the geoid, and it's basically what we think of as mean sea level. That's the elevation we actually care about.
And the fix for this is so elegant. Your GPS device has a built-in map that knows the difference between the perfect model and the real-world sea level for wherever you are. That difference is called in. So it just takes the GPS height, subtracts in, and voila, you get your true elevation. So simple, but absolutely brilliant.
Okay, so we know where the satellite is, and we've got a common map language. But how does all this information get from that satellite down to your phone? This brings us to our third and honestly the most important piece of the puzzle, and it is all about time. Insanely, mind-bogglingly precise time.
The entire GPS system hinges on atomic clocks. These are some of the most accurate timekeeping devices ever created. And they have to be, because if the timing is off by just 1 microsecond, that is 1/1,000,000th of a second, your calculated position is thrown off by 300 meters. So yeah, timing is absolutely everything.
So what's actually packed into that signal zipping down from space? Well, it's a whole package of vital information.
It's got the super precise time the message was sent, a little health report on the satellite itself, and of course, that all-important diary, the ephemeris, and almanac data. That way your receiver knows exactly where the satellite was when it sent the message.
All right, this is it. We have all the pieces. The satellite knows its own position, we have a shared language for locations on Earth, and a timestamp message is flying through space. Now, let's see how your phone takes all of that and puts the puzzle together to find that little blue dot on your map.
Your phone is basically a powerful little mini-computer. First, it locks onto the signals from at least 4 different satellites. It needs 4 to get a 3D position. For each signal, it reads that diary to know exactly where the satellite is. Then, it compares the timestamp in the signal to its own internal clock. That time difference tells it how long the signal took to get there. And since we know the signal travels at the speed of light, that time delay directly translates to distance. Once it knows its distance from 4 known points in space, it can calculate its and your exact spot on planet Earth.
And the most amazing part? It does all of that in a fraction of a second. This whole system, born from incredibly complex physics and engineering, has become this invisible, essential part of our modern world. It gets us to the coffee shop for sure, but it also does so much more. From coordinating global shipping to monitoring the tiny shifts of our planet. The applications are just getting started. It really makes you wonder, doesn't it? Thanks for joining us for this explainer.